So these manufacturers specialize in your food container. So you're going to make a cylindrical soup with volume 250 cm cube. First step, normally when we want to do this question about maximize and minimize, first step, we identify the shape, the unknown. Alright, so the shape here is a cylindrical container. And your material for these two end here is Rn 0.02 cent. Then for the side here is Rn 0.05. Then you have to figure out what dimension that can minimize the cost. So your variable here that you're going to adjust, your variable here will be your radius of your cone, radius of your cylinder, and your height of your cylinder, so that you get the design, which is this design, you can get the material of the surface is the most minimum. Alright, so what is the constant variable here? Make sure this container volume can pick up 250 cm cube. So first step, dapat tahukan apakah variable kamu, tahukan apakah bentuk kamu, dan apakah yang nak maximize dan minimize here. Apakah benda yang kamu nak maximize minimize is the cost building out this cylinder. So if you want to building out this cylinder, you need two circles, top and bottom. And the side here, when you unfold this, you get a rectangle. Right? So now we're going to build up what is your cost here. So for your cost, because you want to minimize the cost, so you must get your equation of your cost to verify the things is minimized. So the cost here to build up this, it will be 0.02 for two circles. The area of the circle will be pi r squared plus the side here is 0.05. The area for this side 2 pi r h. This is your height of your cylinder. So actually this side, this length, when you unfold this length, when you unfold, it come from this. So this is your perimeter of your circle, 2 pi r. So the whole surface, the length 2 pi r, the height h. So length times width 2 pi r h. The cost 5 cents. Alright. So look at the cost formula here. We simplify here. Your cost, we're having 0.04 pi r squared and 0.1 pi r h. Notice that your formula here having two variables. If you want to differentiate, want to minimize, we will make sure our equation must be in single variable, right? So our second step, make sure the formula we change to single variable only. So r and h, the variable r and h, what kind of relationship that we can see here? We can use the information that volume must be constant to find out the relationship between r and h. So volume for the cylinder, it will give us pi r square h is your volume. So area circle pi r square. H, dah dapat volume lah. So this volume is 250. So we're going to substitute. You want to substitute your r or you want to substitute your h? To be easier, you just substitute your h so that your equation C in terms of r only. So we make our h take up. It will equal to 250 pi r squared. So we can substitute here. Therefore, finally you can get the equation C equals to 0.004 pi r squared. So you can notice that now your equation just in terms of variable r, one single variable. So from here we simplify it. We're going to find out the third step. Step ketiga, cari critical number. Step keempat, verify second derivative. Step terakhir, kelima, jawab soalan dimension apa. Okay. So now we're going to find out our critical number. Means we're going to find differentiation equals to first derivative equals to 0. Okay, so this equation we can simplify. Before we differentiate, we simplify first. This can be simplified. R and R here also can simplify. Okay, 0.1 times 250, 25, right? Right? So R we move up, R power of -1. Finding the critical number, differentiate C respect to R, power turun depan, power tolak 1, power turun depan, power tolak 1. Let this equals to 0. Let the first derivative equals to 0. We're going to find out our critical number R. So pindah, kita selesaikan apakah R ni. So darab ke atas, R cube equals to 25. So R cube root of this. So what is the value of this? Tekan calculator. 4.6334. Make sure any decimal more than 3 significant. More than that, then you will save already. Okay, so third step ketiga dapat dah. So tadi sini step pertama, fahamkan soalan dulu. Step kedua, dapatkan equation. Dapatkan equation yang single variable. Step ketiga, cari critical number. Step keempat, kita nak buat second derivative test untuk verify this. So D2C dr square. Differentiate lagi sekali. Power turun depan, power tolak 1. Over R cube. So actually you have your over R cube. Your R cube here is this. So kalau kamu nak masuk balik ini square, cube pun boleh, nak letak ini pun boleh. Mana-mana je. So what's your result for your second derivative test? 0.754. So we justify this result. Kita bagi conclusion. This is more than 0. It is concavity upwards positively. So this is the case of minimum. So we managed to prove this variable R will be the minimum at this figure. So what's your dimension? Means what's your other variable dimension? What's your height? What's your height? Because you already get the radius minimum is this figure, so what's your height? Your height can be minimal. Using back your height equation here, substitute back your R. So your height 3.71 cm. So this is your dimension. What else? what else the question they ask us to do, and then what is the minimum cost. So use the variable. Finally, we answer the minimum cost. We substitute back into our formula, this one. So Rn 8.0